Hi, everyone. Thank you very much for that warm introduction. I'm very excited to be speaking to everyone here at Postman Galaxy on Planet Test and Automation. We're going to be diving into just a sprinkle of chaos. And if hearing the word cloud already just made you feel, uh-oh, you're at the right place. But if when you heard chaos, your heart jumped a little, well, your mind may have also gone, uh-oh, you're still at the right place. We're going to be talking about technology and systems and how this all ties together and breaks and how do we get ahead of that. As we know, our software and technology breaks. The world that we're building relies more and more on the stability of this naturally brittle technology. The challenge we face is how do we continue to innovate and how do we deliver products to our customers in a way that we minimize the risk of failure as much as possible. These days, every single company has some sort of online footprint. With that evolution comes more expectations of our online services. Customers are expecting excellent service 24 hours a day, 7 days a week, 365 days of the year. We can see here that a lot of folks have gone over to Twitter and have complained about their bank systems, their GitHub, their Teslas, everything from Twitter to Slack going down. And we have to also think back about the 2020 that we've just lived. We have seen that our systems have just seen a lot more stress, and maybe you've learned a little bit about them along the way. I did want to take us back into time and see if anyone remembers the outage of 2017 of AWS. This affected a lot of people. This is when the engineer tried to cycle some billing machines, and this took away a lot of the S3 machines. We see here that even it came to the point that AWS couldn't update their status page to let folks know that they were down because the HTML for that page, I just was on an S3 bucket and they couldn't update it. This is why our clouds need a sprinkle of chaos. And I'm not just picking on AWS. In 2019, Azure had a DNS issue that happened in just a little bit of an hour of migrating DNS from one legacy system to Azure itself. This led to a lot of services going down from compute, storage, databases, AD, and this even affected Office 365, Xbox Live. And very similarly, folks took it onto Twitter to let folks know that their platforms were down. And if anyone remembers, just a month ago, we kicked off the year with 2021 with Slack being down. This was, okay, I totally forgot to change the portions of the slide on this one, but this affected the first day of work for many. We see that many folks came over to Twitter, and the tweets that were happening during this outage were actually kind of funny. Slack is being down as we return to work today makes it feel like 2021 is promising. And maybe 2021 is off to a better start, is what some folks in mind. And when you look at the postmortem that Slack actually just finished writing, this was because they had a lot of spike of traffic into their systems, which led for more provisioning of instances. This meant that the network had a lot more limits that they were hitting, which led to more bottlenecks. One of them was the Linux open files limit, and the other one was the AWS quota limit. They were trying to bring more services up so that we can all have Slack, and this allowed for them to have a lot of cascading failures. So today, I'm going to be talking about chaos, but not just chaos, because we see our systems already have a lot of chaos happening to them. But I'm going to be talking about something called chaos engineering. This is a concept that many of folks may have heard around a bit. It has become a little bit of a buzzword. But today we're going to share about how to do this in a way that you're being thoughtful and not just breaking production. Chaos engineering is about doing this in a planned, thoughtful way for us to actually reveal those weaknesses in our systems. We're going to go through how to get started with chaos engineering and some other ways that you can engage with experiments. First, I do want to set the stage with some terminology that I'm going to use through today's talk. We are going to be using the scientific method. So we are going to be talking about experiments, which that means that they come with a hypothesis. And they also come with some aspects of being thoughtful around data and targeting and how much impact your system's going to be having. We're going to define the blast radius as what you're targeting your experiment on. And with magnitude, this is just how intense the experiment that you're unleashing is. Abort conditions can be seen as those safety guardrails of what needs to happen to our systems for us to stop our chaos engineering experiments. And there's one thing to note. You always want to do chaos engineering in a way that you can actually stop the experiment, you can halt it, and everything goes back to normal in your system. The way that we go about it is that we go back to the scientific method and we take a step back. We observe our system. This can be done by observing it from the architecture level, from looking at our system metrics. You want to baseline what your system looks like under normal conditions, whether that's your SLIs, SLOs. You then want to go ahead and form a hypothesis and define those abort conditions. We're going to go through what an experiment looks like in a little bit. You want to define that blast radius. What am I targeting? Am I only targeting one service, 2% of my host, or my entire fleet? Then you go ahead and you run your experiment. You go ahead and you analyze those results. Did you hit an abort condition that you had to halt the experiment? That's also a win. You go ahead and you make those fixes into your system, and you go ahead and you run the experiment again until it's successful. Let's say you ran the experiment and it was successful. Well, you go ahead and you expand that scope. You make that blast radius a little larger. You make that magnitude a little stronger, and you retest the experiment. And lastly, one of the most important parts of this experimentation is that you share your results. You want to share your results with leadership, anyone in your organization. And when you're working in a lot of technology, whether it's open source and software that a lot of folks use, go ahead and share with those communities. Go ahead and tell folks what you learned by doing chaos engineering. I did want to take a moment to introduce myself. My name is Ana Margarita Medina. I am a senior chaos engineer at Gremlin. I've been at Gremlin for 2.5 years, or a little over the 2.5 years. And prior to that, I was at Uber as a site reliability engineer. I've been writing code since 2007, and I've gotten a chance to do a lot of front-end development, back-end development. I did a little bit of iOS and Android applications, and then I transitioned to looking at things from a different side of the stack, from the ops stack. How is it that we keep our systems reliable? And that is when I fell in love with chaos engineering in 2016. Since I'm here on stage, I also do want to call out that I'm a proud Latina. I was born and raised in Costa Rica. My parents are from Nicaragua, and representation really matters to me. So if you can't see it, you can't be it. So just a shout out to my Latinxes in tech. With chaos engineering that we're diving back into, I want to talk about some of the steps that you can take with chaos engineering. You can do things on the resource layer, whether you're maximizing resources such as CPU, disk, I/O, memory. You also want to look at things from the service layer. What actually happens if one of my services fails or one of my dependencies has issues? And you want to look at things from the application level, whether you're doing a little bit more of application level fault injection, or you're just thinking about handling HTTP calls properly or anything like that. And lastly, you want to think about continuous chaos. You want to think about ways that you can automate this, whether it's using the API, whether it's building it into your CI/CD so that every single time your code gets pushed out, you're actually running chaos engineering experiments as well. And you also have the portion that if you bring it into your blue-green deployments, canary deployments, you get a chance to just be able to do this continuous chaos. And you want to automate it to prevent a drift into failure. One chaos engineering experiment that allows folks to conceptualize chaos engineering is a way for everyone to validate monitoring. As we work around with a lot of our customers, or I talk to a lot of folks in the industry, we hear that sometimes people don't have monitoring set up for a lot of critical systems, or sometimes they've just brought in their monitoring tool. They hope that they configured it properly, but they don't know until that pager goes off. So a way that you can just use chaos engineering easily is by making sure that you set up that monitoring. And you can easily do that by just running a CPU experiment that's targeting 50% of your nodes. You run that for a 60% CPU spike. And that abort condition is if your application is not responsive, you go ahead and you halt it. You have to go ahead and form a hypothesis and abort condition prior to doing prior to executing the chaos engineer experiment. So we've already defined our abort condition. When we look at our hypothesis, you want to look at it in a way that when I inject 50% CPU into my nodes, I expect to see it on my monitoring. And this is a great way for teams to just get a little bit more comfortable in chaos engineering. It wouldn't be an API conference if I don't bring up a curl command. So we can see here easily that with just this curl command to our chaos engineering tooling, we're able to just say, select all of my hosts in this 50% and execute a CPU increase of 300 seconds for all my cores at 60%. The best thing about using something in the API is that you can just automate it for it to get stronger and stronger as it goes through different development cycles of it. Another way that you can look at chaos engineering is to actually think about what happens when one of my services or my application suffers a dependency loss, because we don't want our customers and our users to notice it at all. One way that you can replicate that is by having some latency into one of the critical dependencies of your application. One of the ones that I get a chance to play around with a lot is working around cloud native and specifically around Redis. Let's say that for this one, we just want to inject 400 milliseconds of latency into one of the critical portions of our applications. My abort condition is going to be that when my application is unresponsive, I want to go ahead and stop it. When I start seeing 400, 500 error codes, I want to go ahead and stop it. And if there's any response rates that are actually increasing, that might be another way that I can see, this is actually not meeting the standards that we give to our customers. The hypothesis is that when my caching layer has a latency increase, my application should work without any issues. And here in the API call, I've just gone ahead and changed the type of experiment that we're running. And we're only using it for this one application called the Redis cart. We go ahead and run it for 300 seconds and inject 500 milliseconds of latency. And we're whitelisting our API.gremlin URL. And we're also just whitelisting our port 53. But I was going to talk about just cloud needing a sprinkle of chaos to bring it back to the outages that we covered earlier. But for anyone that's looking at hybrid cloud, multi-cloud, or just has a lot of dependencies of the cloud, you're also able to use chaos engineering on a way to actually test if you're resilient of one of your data centers going down, whether it's one of your regions, whether it's one of the cloud providers itself, or maybe you actually want to see what happens if I replicate the 2017 S3 outage. We can go ahead and form that chaos engineering experiment by just doing a shutdown attack. Let's say that blast radius should just be 70% of the resources on that cloud provider. Those abort conditions are going to be similar to the first ones that we defined. Your application is not responsive. The traffic is not failing over to the new provider, to the new data center. So our hypothesis goes back to being when our data center in one cloud provider has an issue, our backup systems in another provider will actually be available. This is a great way to conceptualize those evacuation plans, those failover plans, and really make sure that you're testing with your teams that the processes and the systems are in place for them to be ready. We can take a look at that API call, and you can see that for this one, yes, we are doing a random selection of hosts, but with this one, we're also passing the cloud provider tag of AWS. You can easily say any other cloud provider, or maybe you want to tag your host when they're in a certain region or a certain dependency that they're actually having. But one of the biggest things with chaos engineering is that we want to go ahead and practice. It's not about just me coming here and saying all this conceptual chaos engineer experiments. You want to go ahead and you want to run them with your team, with your organization. So one of the ways that you can actually go about doing that is by coming together and running a game days. This is an opportunity for your team to execute 1, 2, 3, 4 experiments. And sometimes some teams don't even get to run the experiments. They just end up learning so much in the hypothesis of thinking of the mental models, sharing knowledge of incidents that they have seen at the organization, or sharing a little bit more, maybe sharing a little bit more about how they built the systems and the services, because maybe there are those legacy engineers that are there. And that is one way to put it into practice. Then let's say you only got to the hypothesis that time. Make sure to schedule a follow-up time so you can actually execute one of those experiments and learn from injecting failure into your systems. Another way you can practice chaos engineering things in your organization is by doing a fire drill. A fire drill is a way for you to actually practice the processes and the people side of actually doing chaos engineering that allows for you to make sure that you're ready for that incident. You're ready for where your on-call rotation kicks in. And this one's really critical for any portion of the industry that we're in right now. I know that when I started being on call, I got thrown a pager and was told, hey, good luck, here's the run book. And I always say, what if we were actually onboarding all of our engineers into on-call in a much nicer, better way? And what I mean is that we actually give them that pager, we give them that run book, but we go ahead and tell them this is when we're going to do some practice training for you to be able to be in the mindset, to be ready to handle on-call, be able to escalate to the right people, be able to know who the incident commander is, who you need to loop in, when you need to loop someone in for internal comms or external comms. Those things are things that you need to figure out early on. And to bring it back to chaos engineering, this is about learning from failure and learning via experimentation. So the practices that I just mentioned are ways to do it by executing these experiments. But I also say that we should always be learning from failure, because I mentioned those 3 earlier outages, and there's many postmortems written like it. Or you might actually want to go read on those postmortems. You can actually learn a lot by reading those postmortems and learning from failure. How is it that other organizations and systems are finding vulnerabilities in their systems? And when you look at those things, you're actually able to think about other experiments that you're actually able to run in your organization. And at the end, you're building a complex distributed system, and there are things that you must test for, or you're going to suffer an outage. As we heard earlier today, technology and software is really brittle, and we have to go ahead to get ahead of that. Failure happens, and you want to run chaos engineer experiments on everything. Go ahead and run it on your CI/CD platform. Go ahead and run it on your monitoring. Validate your auto-scaling policies. Make sure that everything is being run properly on production, testing, Q&A. And I mentioned earlier a little bit about continuous chaos. You want to make sure to automate it in all your pre-prod environments prior to automating it into production. It's just you want to learn how to crawl, walk before you can go ahead and run. And with that, I would like to offer y'all some stickers from the chaos engineering community for attending my talk today. If you would like to get this cool sticker sheet that has one of my favorite stickers is that little terminal with the spade, or the tea makes it all better is also another one of my favorites. Head on over to gremlin.com/talk/postman-galaxy. And we would also like to welcome you if you would like to we would also like to invite you to join the wider chaos engineering community. This has over 6,500 engineers across the globe that are just getting started in chaos engineering, that are actually in testing and QA, and are trying to understand how is it that you can build more reliable systems apart from just doing testing. So you can head on over to gremlin.com/Slack and go ahead and join it. And if you have any questions, I'll be around for a bit, and you can also message me via Twitter or anywhere on social media. I'm going to be at Anna_M_Medina, or you can reach out via email at Anna@gremlin.com. And if you do want to give Gremlin a chance to a try, you can go ahead and try Gremlin free via go.gremlin.com/Anna. And with that, thank you very much.